Graphing. All right, sketching from a list of conditions. So what I'm going to start by doing is looking at my list of conditions and getting a sense of what kind of scale I'm going to use on my axes. Okay, I got some, let me see, I got y is minus infinity here. I got y equals 3. My x values are 0 and 2. Okay, so when I draw my axes, I want to keep that in mind because it'd be a pain to have to erase because I don't have enough space. So I got that minus infinity, so I want to give some space up down below. And got to at least get y equals 3 up above. So I think this should be okay. The highest x value is 2, so why don't we put 2 over here. Okay, I also don't want to have a final drawing that's too cramped. It's going to be hard to look at. Okay, so I got y is equal to 3 over there, so I'm going to put at the top here, I'll put 4. Just to give myself a little bit of space. So I'll put 4 up here. And the x values are 0s and 2s, so I decided to put my 2 there. Anyways, what else do we need? 0s and 2s, and I got the 3. I'll label the 3, why not? Okay, I think I'm ready to start. Now, my recommendation is to look at these conditions and choose the easiest ones to start with. And those would be these guys down here. So number 4 says when x is 0, y is 1. When x is 0, y is 1. So x is 0, y is 1, that's this point right there. And over here I have x is 2, y is 3. X is 2, y is 3. X is 2, y is 3. So my function actually hits those 2 points. Now when x goes to 2, the function approaches 3. So how can I put that into my graph? Well, so x goes to 2, that's not a one-sided limit. That means from both directions, I have my function going into this point here. So from the left and from the right. Okay, so I was able to draw a little bit more of my graph here, and that represents number 4 here. Okay, so that's done, that's done, that's done. Now, this one looks like it's easiest. So when x goes to 0 plus, so when x goes to 0 from the right, I'm getting 1. So that would say that I'm going to have a little chunk there, right? So x is going to 0. So you can draw a little arrow to convince yourself of that. When x is going to 0 plus, a little red arrow is pointing towards y equals 1. All right, what's the last condition? Last condition is the minus infinity there. So when x goes to 0 minus, so when x approaches 0 from the left, my function shoots down to minus infinity. So what I need here is a descent like that. I put a little arrow to indicate. And just the way I've drawn it, it's meant to indicate that this chunk of the function is just getting closer and closer to the y-axis here. And this chunk satisfies this last condition here. All right, so now I'll just connect the dots to make a continuous function. So whatever, it doesn't really matter because I've already satisfied all my conditions. So I can go like that. And then up here, I can go, or whatever, does not matter. And you can go through the 1, 2, 3, 4, 5 again and verify that this function, whose graph I've drawn here, does indeed pass all these tests.